Hello and welcome everyone. In this video we will see how much rocket fuel would it take to travel 1 light year, around 5-6 trillion miles. Thank you for clicking on this video. It is presented to you by Question Answer. I thank Steve Baker, Andy Duffell, Ben Wright and Toby Dillon for sharing their answers to this question with us. We'll start with Steve Baker's answer.
Once you're actually moving in the desired direction and far enough away from any large gravitational sources, none, no fuel whatever. The two Voyager probes are traveling at about 17 kilometers per second and very gradually slowing down. The speed of light is about 300,000 kilometers per second, so they should cover 1 light year every 20,000 years. And it's doing this using no fuel whatever.
What do you think? We will continue with Andy Duffell's answer.
Depends how quickly you want to do it. The important point to understand is that you don't need to be firing your engines all the way. You can just fire them to get you up to speed and the coast the rest of the way, because that's how space works. Once you're up to speed, there's nothing to slow you down, so you just keep hurtling along. You only need rocket fuel for that initial push. This is Voyager 1, currently beyond the edge of the solar system and into interplanetary space. It's doing about 61,500 kilometers per hour, which means it will cover the first light year outside the solar system in about 17,500 years' time. I've assumed velocity remains constant, which it won't, but it's close enough. It required this much rocket fuel to do so. That's a Titan IIIE launch vehicle, with a total of about 350 tons of fuel on board. If you wanted to travel that light year faster than 17,000 years, you'll need a bigger rocket and more fuel, or to plot a course that includes more gravity assists from the Sun and Jupiter before leaving the solar system. Voyager actually isn't our fastest ever spacecraft. The Parker Solar Probe steams along at about 10 times the speed of Voyager on its close approaches to the Sun, so I imagine it could outpace Voyager if it could be put onto an escape trajectory. The maths answer that question are way beyond my abilities though, as it would involve a lot of complex orbital trickery. Things get complicated if you want to actually slow down at the end of your 1 light year journey. To do so requires the same amount of deceleration as the initial acceleration you applied, which means your spacecraft now requires a lot of fuel on board, making it substantially heavier. This means you need a lot more fuel for your initial acceleration, because you're so much heavier. This is why many interplanetary missions like the Voyagers are designed as flybys. It's a lot easier and cheaper to do a flyby than to park at your destination. If you want to get cute, you can use gravity assists from planets to help slow you down, but you're also going to need some fuel to do it.
We can continue with Ben Wright's answer.
Big companies usually take one of two routes to hire globally. Companies that know they're going to stay in a market for a long time, and plan to hire at least 15 employees in that market, typically set up an entity. Having an entity allows them to legally hire and pay employees in that country. But entity establishment is costly, time-consuming, and not the ideal choice for every employer. Companies that want to hire in or enter new markets quickly and compliantly without entity establishment can partner with a global employer of record, EOR. Companies tend to have smaller talent pools, usually under 15 team members, in countries where they partner with a global EOR. In this situation, the global EOR partner becomes the legal employer of the company's talent, handling everything from compliant onboarding to benefits and payroll. They take care of the back-end details while the company maintains direct control over the day-to-day activities of its talent. The global EOR model means international hiring is no longer just an option for larger companies. If you're a startup or mid-sized business looking to bring in worldwide talent, consider simply finding the right global EOR partner to scale your business.
We continue with Toby Dillon's answer.
There are actual calculators for this, one of which I use to determine travel time for a world I'm building. The amount of mass you want to push and the acceleration you want to have factor heavily in the equation, especially the acceleration.
The video is over. Thank you for staying until the end. Remember to subscribe if you like the video. The likes also help a lot for referencing. You know what you have to do. Friends, it's now the end of this video. Remember to leave a comment to tell us if these answers are more for you. See you soon.